Hey guys, it's Vince. Today in this video we are covering the second portion of the first video where I covered setting up an advanced G540 system for a client. This one of course has the dual relay system to cycle the direction of the spindle in both forward and reverse direction, as well as having the ability to manipulate the spindle speed. That being said, the system is on. I disconnected the fan so I don't have to speak over it right now. We do have a UC400 Ethernet controller hooked up. I'm inside of Mach. I'm going to cover the breakdown of how to set up your system in Mach, and then we're going to cover exactly what happens and my hardware setup for the VFD, and to show you the spindle test configuration. So first we're going to come over here to config. I'm going to go to ports and pins. We're going to go to our output signals first. On the G540 you have two available outputs. They are terminals 5 and 6. Okay, output number 1 is port 1, pin 17. That is the first relay. You want to enable it. Of course, you can see the green checkbox. But with us having it enabled, this one I've allocated to forward direction. This relay will cycle the unit to go in forward direction. Output number 2, enabled port 1, pin 1. Okay, these settings are mandatory, and you can arbitrarily set up the direction for whatever relay you'd like. Once again, I've allocated output 1 to be forward and output number 2 to be reverse, and they are two allocated relays. So you can see how this is set up. We're good here. Once you've got this set up, you're then going to come over here to spindle setup. You're going to come over here to relay control, and you can see where it says disable spindle relays. If this is checkboxed, you want to uncheck it so it's active. Your clockwise, you then will allocate your relays. Clockwise rotation output, I selected number 1. Counterclockwise rotation, I selected number 2. You can see in Mach 3 it says M3 and M4. Those are the codes that you can type in MIDI in order to allocate and trigger the spindle to go clockwise or counterclockwise, and M5 is to stop the spindle. Okay, now you're going to come over here to motor control. Use spindle motor output. You want that checked. PWM control. You want that checked. PWM base frequency. Now I've gone online and I cannot get over how much misinformation is out there. You have guys using 50%, you have guys using 20%, and the problem is that when they get something to work, they don't really understand why it works, and therefore they just put in arbitrary numbers, and as long as the spindle does what they think it should do, they leave it. We're going to cut through the BS, and the PWM base frequency for G540 I feel works best at 10. And the main reason I say that is the RPM stays more synchronized, because again, PWM base frequency is based on the voltage at which the PWM signal is going through. You have 0 to 10 volts, that's what the G540 utilizes. And again, we want to set it up to where your frequency is going to give you the most positive form of RPM in terms of less fluctuation. Minimum PWM base. Now I put mine at 5%. And you'll see why as I cover this. You can select arbitrarily whatever base you'd like. It's just going to increase the idle speed of the spindle. Now keep in mind, you want to set this minimum PWM signal voltage so that your RPM on your spindle does not overheat. And that means that if you're using an air-cooled spindle like I am right here, I want to keep it at about 1500, 2000 RPM when you turn the system on. I've seen guys have theirs up to 5,000, 6,000 RPM when you turn the system on. That's totally up to you. It's not required. Again, you're not going to be cutting at this speed. I will say that again. This is not a speed that you will be using to perform any type of jobs with, typically. And why I say typically, if you're doing something like, you know, just barely kissing material, that's one thing. You don't want to use the spindle at an RPM that it's not designed for. So check with your vendor, make sure that the minimum RPM is where you're going to be cutting as far as usable RPM. Minimum PWM is the idle speed of the spindle. Okay? So again, I've set my minimum PWM to 5%. Once you've done that, you're going to click apply. Okay? Once that's done, we click apply. Once that's done, we click OK. Now what we're going to do is we're going to come over here to config, and we're going to go down here to spindle pulleys. Now, I get this question a lot, there is no pulley on my system. Okay, it's just a direct drive spindle, we're not dealing with pulleys. Okay, Mach 3 doesn't know that. All you're going to do is select your pulley number, and in this case there's only one, in most cases there's only going to be one. So just select your pulley, select minimum speed 0, maximum speed is based on your RPM rating of your spindle. Most spindles are going to be 24,000, most. If it's not, you would just naturally set that up to what speed you'd like. Now, you can select a different minimum speed. Now, you heard me say I set the idle at 1500. You could put that in here. It really isn't going to matter, okay, at that point. Really, the ratio you see here when I said ratio 1, this is just meaning it's a linear motion, okay? You really don't need to mess with this, and I'll show you why, because if you get the PWM ratio correct, you're going to see your spindle will stay virtually on point within, give or take, about 100 RPM. So everything here is set, very, very simple. We click OK. Okay? I've seen guys go into motor tuning and start messing with spindle settings. This is not required. Okay? I've seen that online. It's BS. Don't need to do it. Okay, now, Mach 3, the only other setting we got to do is we're going to go to our ports and pins, and we are going to go to motor outputs, and we're going to come over here to spindle. Now you can see this is where you actually set up your axis for your system. This is already done to match G540. Over here, spindle, you're going to check that. You're then going to set your step pin to 14. Now, your direction pin is irrelevant, because all you need is that pin number 14, because that's going to allocate spindle speed. We don't need to mess with anything else. You do need to come over here to step port and direction port and allocate these to step port 1 and direction port 1. This is a must. I've seen systems set up online where they actually had the spindle operating with these set at a different actual configuration. I don't recommend it. This is the basic setup, and this works flawless. Now, prior to doing all of this, because once this is set, your settings in Mach are all good. Prior to doing all of this, you must install Mach 3 from the beginning. And when I say that, remove your version of Mach 3 and copy down all your settings naturally first. And whenever you introduce something like this, a new piece of hardware, whatever it may be, I highly recommend you reinstall Mach 3. This way you start with a fresh piece of software that hasn't been manipulated. It's the easiest way to isolate any potential issues that arise. Okay? It's more work, but it guarantees that you're not messing with old software that may have glitches in it due to whatever settings you had prior. Very simple to do, yet I get millions of questions on it, and it seems like there's always a lot of resistance to do that. I don't know why. It's very quick to do, and if you copy down your settings and you have a backup, it's fast. So now what I'm going to do is I'll piece in how we cover the VFD and how this is set up to support this system. Okay guys, you can see here we've got the VFD set up, got the spindle set up, and this is just a test configuration. I'm not using anything out of the ordinary. I'm just testing everything. I got my silicone mat here for the spindle. VFD is set up. This VFD has a full wiring diagram for the DB9 connector with mounting bracket that I've integrated. Now I'm going to show you how clean this can be done. Okay? This allows the client to wire this in seconds. Watch this. Look closely. Pop this. That's the way this should be done. We have thumb screws, or excuse me, thumb nuts right here for quick mounting, metal bracket, DB9 connector. Here's your jumpers, and everything is connected. White lead DCM. We've got a reverse lead for blue. Forward is black lead. ACM is orange lead. 10 volts is purple lead, and VI is brown lead. Now, if the client has any questions as to what is what, everything is allocated here in color configuration. So it's very simple to hook up and very simple to work with. Now you can also see I've got the jumper set to the left side, which allows us to manipulate the actual spindle speed through Mach 3. This is a must. If you're working with this unit, the stock setting of this jumper will be on the right side. You want to be on VI. Let's see if I can just pan it up. You can see VI right there. So that's a must. Okay? Now, as far as the breakdown of what these control, we can cover that, and I'll put that in the video as well. I will do that after. I'll put it on the screen so you guys can see it. I'll edit it in. But right now, excuse me, you can see we're at forward. I will be able from the software to switch to reverse, and I will be able to control spindle speed. Now I've got Mach 3 right here. I've already set my spindle speed at 1500. Now why did I do that? Because that's the minimum speed, once again, that I want to idle at. I highly recommend you do that first. Do not leave it at 0. If you leave it at 0, you will get an error message. And do you know what that error message is? For those guys out there that have already done this, PWM bump to minimum setting. Okay? And what that means is, because I got questions on this too, is that your PWM signal that we've set at 5% for this particular unit is going to be set at that minimum level because you cannot go to 0 RPM, in which case it's beneath the actual percentage we put. So if I put 0%, for instance, on the PWM signal, this would go away. As soon as I exceed or go with the PWM signal, you'll see this go away. Watch. I'm going to clear this error, and we're going to come over here one more time. We'll enter it in one more time. As soon as I enter that, you don't see that anymore, and I'm going to hit spindle start. Very simple. I'm just going to press the button. Got the tape on, and you can see she's spinning. Okay? And again, she's at 1500 RPM. Now, if you look at the VFD, you can see we're very, very close. Now, of course, Mach 3 is not going to read the RPM exact. Why? There is no way for Mach 3 to read RPM. There's no tachometer. So I get questions on that a lot. You're going to have RPM fluctuate, and you can see it's very, very close. We're within 100 or just under 100 RPM. This is idle speed. Once again, he's not going to be doing cutting at this speed. You can see our rotation. This means that we're displaying RPM. When you're selected under rotation, I get asked, how do I actually move the LEDs to give me different readings? Just hit shift. And you can see now we've got hertz, we have amps, hit it again. Now you have amps, you have rotation, and you can keep doing this until you cycle to what you want to read. Amps is very good to see, especially if you're using a new end mill. I've said this in previous videos, to see what kind of load you're putting on your spindle. The higher the load, usually the duller the end mill. It's a good way to determine if you need to replace it. Anyways, we are moving in forward direction. Power is on, of course, and our rotational RPM is set at 1500. Now, if I decide I want to program in any speed, let's say 5000. Now she's accelerating. You can check the tape out. Okay, once again, we're still moving in forward direction, right? So I'm going to go back down to 1500. Hit enter. She's back down, and now I'm going to go over to my MIDI, and I'm going to select the opposite direction. Once again, we are moving forward. I'm going to type in M4, and you will see her stop and then switch over to reverse. There you go, same speed. And you heard probably the relay click. So again, you can see exactly how this works. If I want to toggle a different speed, I just come up here to MIDI, go to 5000. I'm just arbitrarily setting this. I can go up to 24, but that tape will get loose like that. So we'll slow it down. There we go. Okay. But It's that simple, guys. I'm going to turn off the spindle now, I'll pull off the tape, and I'll show you going to full speed because I know I'm going to have questions on that. We'll go full speed. Of course, we'll go full speed. Turn it back on. You can see the spindle actually, as soon as torque is increased in the motor, you'll see it actually move. We'll go to 24,000. You'll see it go right up. And you see just how smooth this is and how quiet it is compared to when you're dealing with a regular wood router. Once again, very, very, very close. Very, very close. Couple hundred RPM off and we're right on. Turn it back down. Come back down to 1500. We'll switch direction. We're in forward rotation right now. Switch direction once more. You notice I'm only doing it at low RPM when I switch direction. Now we're going the opposite direction, and you can see that right here. Reverse. I'll switch it again to M3. You'll see it switch over. Forward. One more time. And now it'll switch over. So again, guys, you can see once again how small my leads are. Do you see the length we have here? And if you look, we have a nice, beautifully machined edge that when we set the cover on, we're clean. There you go. This supports the mounting bracket, supports the cable. This is one of my G540 motor cables because it's double shielded. And being our leads are so short right here, we don't have to worry about noise because we're literally running about maybe 3-inch leads. Every ferrule is soldered on as well as crimped. It doesn't get any easier than this. And again, the thumb nuts allow for easy servicing. He can remove this at any time and he's set to go. So, very, very simple setup. Not a cheap setup because there's a lot of work here. I'm not going to lie. Between the system, this, and the way we have it all configured, it's set so that minus an ATC spindle, this is as close to autonomous as you're going to get in the terms of end user support. Because at any point in time he's controlling this. Once again, we switch direction. Boom, there's forward. Now, the next question I'm going to get is, Vin, how do I set up my spindle settings so I can have control? That's a very good question. Okay guys, in this portion of the video we're covering the general VFD programming parameters for your spindle that's powered by an HY VFD. These settings are only relevant to using an HY VFD because these settings are derivative of that unit. Your spindle motor is irrelevant as far as the brand, but you do need the specs of the spindle motor, which are inscribed on the unit, laser inscribed they are, on the unit's body. You'll need to input them as we go through. You can see in this first paragraph that's slightly long, we're discussing how to reset the VFD to factory settings. Now you can do that, but I have to be honest, if the unit's new and it hasn't been manipulated, you're pretty much set in using it just the way it comes out of the box, because as you go through these settings that you're going to manipulate, if you notice something different, you're just going to put in the correct one anyways. I have yet to have any issue with that. If you are in doubt, naturally go through resetting the VFD to the factory default settings. Okay, please input these settings in this order, and these are the spindle's default VFD programming, which is essential to get the unit started without damage. These are the basic settings. Now, when I say basic settings, you can go on these CNC forums, and they're long, and you'll find guys who feel they're an expert, and they'll tell you a million different settings to adjust. Here's the thing. If they don't know what applications you're using your router for, it's best to just start with default settings, because I always say crawl before you walk, and see how the unit performs for your applications. If it performs fine, why mess with something that isn't broken? A lot of times guys go down a rabbit hole where they think this guy knows more than them, and instead of just starting and saying, hey, let me see how this all correlates, start somewhere fresh,
see what happens, and then make adjustments based on that. Your VFD does have controls for deceleration, acceleration speeds, all that neat stuff. But stay with the basics first, my recommendation, and then make adjustments. Once again, please input these settings in this order. Step 1, set PDO 5-400. These are all your frequencies, just so you guys know. Step 2, set PDO 4-400. Step 3, set PDO 3-400. Step 4, set PDO 7-2-400. Step 5, PD 144 equals 3000. That's once again if your spindle is at 24,000 RPM. We want to make sure that the top end hits the maximum RPM rating of the spindle, and that's what this setting is for. Most spindles, once again, are 24,000 RPM, so again, this setting is pretty much general. Then set the following parameters below. Step 6, PD 141. Set this to the spindle's voltage rating on the side of the spindle. Once again, it's inscribed on every spindle and laser, and you'll see it. Step 7, PD 142 equals input. The amps written on the side of the spindle. Once again, these specs are inscribed with laser on the side of the body. Step 8, PD 143 equals 2. And step 9, PD 070 equals 0. This should get your spindle operating if you're going to manually be operating your spindle. Now, if you plan on manipulating your spindle speed with Mach 3 through PWM, then change the following settings below additionally. We have step 11, PD-001 equals 1. This is setting up so that you're not using a manual potentiometer, you're using Mach 3 to be able to control the RPM. Step 12 is PD-002, and that is only going to be adjusted if you're using a forward and reverse relay, as I did in this video. And the reason you're doing that is so you can select forward and reverse. If you're just using forward, it's irrelevant to set that because you're just turning the spindle on. It's only going to cycle on one direction. So again, PD-002 is only to be set if you're using 2 relays. If you're using a single relay just to cycle on forward direction, this is not required to be set. Other than that, now if you are actually going to be controlling speed, you will be setting PD-001 equals 1. So if you have a single relay, once again, PD-001 equals 1 will be set to 1 if you are using one relay and you're expecting to manipulate the speed through Mach 3, just to be clear. Also configure the VFD jumper that's located under your VFD's cover where you attach its power cables as illustrated below. It must be on the left side labeled VI, and that's when you're looking at the unit. Okay, so just so we know where we're at, you can see it says VI. I showed you this later in the video. You'll see that this jumper needs to be over here. And this once again allocates us to be using Mach 3's algorithm to control the VFD. We need that. We need to make sure that the VFD is configured in this configuration for that, and you'll be all set. So again, this covers your general settings. I've seen lists of settings that go on. And once again, until somebody knows exactly what you're doing, I recommend just staying with the basic settings. And these are basic from HY. So again, I hope you're taking notes. And you can always naturally pause the video, and that's why I'm going really slow, and you'll be all set.
Okay, but if you notice these connections, and this is another question that I haven't heard asked, but I'm going to cover it. You'll notice you have DCM on top, and you also have DCM on the bottom. It does not matter what connection you put into what actual allocated terminal location as long as it's the same. Okay, so if you see a DCM here and a DCM here, it's the same. Don't worry about it. It's when they're individual, you must go to that individual location. Okay? Now you notice I didn't cover how this VFD is connected. And the reason I didn't is because that's all over the internet. But if you want to know how it's connected, it's very, very simple. This is a 110 volt VFD because that's what my client has. R and S are actually R is your hot lead, S is your neutral, and then you have your ground lead. Okay? R once again is hot, S is neutral, and your ground lead is on the far right. It's terminal 9. Okay? U, V, and W are all power leads for your spindle. It does not matter how you connect those in terms of where you connect them on the VFD. Why is that? Because it's a 3-phase output, so it means every line of those 3 are hot. So once again, UVW, hot, hot, hot leads. Any which way you want to put it. If you connect it any way you want, you're going to get there. The only lead you got to be concerned with this motor connecting it is pin 9, which is your ground. You do not want a ground going to a hot output lead or your SOL. So again, once again, the connection on the spindle, a joke, UVW, all 3 power leads, the one ground. The one ground goes over here to number 9, okay? If I get a question on how to connect the spindle, I'm going to direct you to the video, and I'm going to take you to watch it. If you still don't see it, you're going to watch it again. Or at least, I'm going to direct you to watch it again, because I get a lot of guys that will watch 5 minutes of a video and say, I don't understand. Well, you don't understand because you're going too fast and you're not paying attention and you're not writing things down as you should be. Because if you really want to learn, that's how you learn. And I'm telling you that right now because my time is just as precious. What I'm showing you right here is to make your life easier. And especially doing stuff like this, which I know no manufacturer does, no vendor does it, because they don't have the equipment, they're not going to invest the time. This is the right way to do it so your client knows exactly what's going on, and that's exactly what I did this for. He can service this at any time, and he knows Mach 3 settings because they're right here. Everything is right here for him, and he's set to go. He requested that I ship this unit pre-programmed and ready to go, plug and play. That's what he got. Ready to go, plug and play. I mean, that's what this is. When I get asked how much these systems go, it all depends. I'm going to tell you, with the VFD, with the system, is just under $3,000. And I'm proud of that because I can tell you right now, like I said, with the amount of work that's put into this in a plug and play configuration, I mean literally plug and play, he's just going to connect the spindle. This will be programmed before it leaves. All he has to do is plug this in, turn this on, set up Mach 3, and he's ready to go to work. And then you consider the fact that the only missing ailment that his system will not have pending he decides to upgrade in the future would be an ATC format. This is very, very close, only because it's got the manipulation of speed and both directions. So again, you've got a lot of opportunity with this. These are systems I get a lot of requests for. And again, we keep it clean. And there you go. So again, guys, I hope that the video has been helpful. I hope you watch it all the way through.